Hallo miteinander, schön, dass ihr gekommen sind. And that's about all the German I know. So, I will present in English. I am representing Artificialy. We are an artificial intelligence company. We're actually pretty young. We're just hitting our 3rd year now. But we are an unusual startup because we have a really experienced leadership that's been doing AI since the 80s. So very, very early. And today we want to present something that has to do with our partnership with Elma. And I would like to present to you some solutions that we do with them where we combine hardware and software. So on the left, you will see some of the solutions that Elma presents. On the right, some of the technologies that we cover. We are also peculiar because we have engineers specialized in all technologies vertically. So we have our computer vision specialist, Damiano, today that will present after me. We do Edge AI, we do NLP, so a lot of these big keywords that you've probably heard from AI, we actually cover that with specialized experts. And the way we function is that we then put these figures together in teams, and we can present always the experts to the companies we work with. We are quite unique for this reason in the industry, because we bring in the best of high tech, the best of research. Our leadership come from ITSIA, which is the Institute for Artificial Intelligence Research in the canton of Ticino. So we're coming from Lugano, but it's actually sunnier in Winterthur today. And we also have a very strong business mindset. So we help with really understanding components of project management and bringing the project to industrialization and implementation for our clients. These are some examples of clients that we work with. You actually will see from banks to industries to Sony, but probably a big name, and we've done a lot of projects in a lot of fields. Today, Damiano will present something that has to do with computer visions and neural networks, and I will leave the microphone to him. Thank you.
Hi, hello. I'm Damiano. So a bit of context before we start the presentation, because we are in near world to some of you, because we are a bit higher. We are not talking of very micro technology. We are talking of middleware technology. So we consume not milliwatts, but some watts. 1, 2, 3, 5, 10, sometimes hundreds, but sometimes. So what is the context? We developed neural networks that are a very powerful instruments for analyzing data. And what is the context? For example, to monitor some environments. Let's think, for example, a project that we did is a driver monitoring system, where we are able to monitor the face of drivers and detect if it is drone, if it has attention to the road, and so on. Or we can do some application where not only monitor the environment, but also to take actions. So to decide what action to take. For example, in an autonomous driving company, we can decide to turn left or other decision. But in general, what are neural networks? A bit of context also in this field. I know that most of you knows about neural networks, but neural networks is a flow of informations from some sensor, in this case cameras. So you have unstructured data that is pixels of images, and you elaborate these flows for producing a result that in this case is the meaning of the digit that you see. These flows contains a lot of operations that are the white operation here. That is for example, standard multiplication or sum between your input data and some parameters. The parameters is the essential part of neural networks because they are the instrument that you got the result from your input signals. And these parameters are learned during the training process. Later we will talk about the training process. Continue. So you have a very powerful instrument. You have a lot of operation to compute the information. We are talking about thousands or millions, sometimes billions of operations that you have to perform only for producing one result. So you need powerful instruments. One choice is to use server. So you have camera in different locations, you send images across the networks, and you elaborate the results inside the server, and you get back the answer. The second option is to use embedded device. Because nowadays there are a lot of companies that are releasing AI accelerator for elaborating heavy neural networks and so on. But why choosing embedded device instead of using a central server? There are a lot of motivation. Now we are talking about some things. The first one is lower cost, because if you have only one camera, you need only one embedded device, and the cost is much less compared to having one server. There's things also to the infrastructure, because you have to think also the infrastructure for managing all the data flows to the server. Here an example for these images, very particular. For example, here there is a woman in her bedroom that comes from a very famous vacuum robot maker. These images, that are very private images, were published on social media. We don't know the reason, but this is because this company has to send the images that was taken by a robot vacuum to a central server. But let's think at an example. For example, an hacker can enter on the central server of a company, or can intercept the communication between the camera and the server. Anyway, all this problem can be solved using a embedded device, because you elaborate images in the exact location where your camera is. And after the elaboration, the images are destroyed. Other example, autonomous driving car. If autonomous driving works with central server, you have to cover all your country or your public road with mobile connection, and you have to ensure that it is stable and it works always, because if it doesn't work, there is a security issue. This is the reason why no autonomous driving company is working on central server, but all the solutions are embedded. Okay, with lower energy consumption, not like we presented before, we consume some watt, but anyway, we can use batteries, we can use passive dissipation and so on, compared to server that consumes hundreds of watts. Okay, real-time inference, I'm talking about 30 or more frames, so images elaborated per second, so a lot of information elaborated. This is impossible in server situations, because the time that is needed for the latency of the network is too high for our needed. So all the real-time inference, I'm talking about 30 or more frames per second, are performed via embedded device. This is another reason, okay, because we are a central server. If the server is down, all your entire system stops working. If you have embedded device, for example, for monitoring some environments, if one stops working, you have other sensor that continues to capture data and to elaborate data. This is a very interesting motivation, because as I said before, there are a lot of companies that are working on their solutions. For example, we have some solutions from NVIDIA, but also Meta is releasing some of these solutions. Here we have NVIDIA IDO, and these are the performance. What means for performance? This is the rank of trillions of operations performed by 1 second. So there are, for example, let's take the IDO 8. We have 27 trillion of operations performed in 1 second. And this is crazy. And we have two types of operations, the int8 and the floating point operations. As said by the presenter before, of course, int8 are faster, easier to develop, to perform. So the performance that you reach with int8 is much bigger compared to the performance of floating point operations. Here are some solutions. So this is the best RTX GPU. So this is server. We have to compare server with some of the solution of embedded devices. This is crazy. This is for autonomous driving company that performs more than 100 of tera operation per second. But there are also cheaper solutions like the Jetson Nano, that is very famous, from NXP, the Halo 8, that are in the range of 1 up to 20 tera operation per second. And of course, the solution is cheaper, consumes very few watts, like 5, 10. For example, or in series consumes up to 70 or more watts, and so on. So if you choose the cheaper embedded device, like just Nano, for example, you have some problem because you cannot elaborate a lot of information, and you cannot have very big neural networks. So what are the problems? So you have to optimize your problem. Okay, let's see. Well, this is a very famous neural network. I think that all of you know these neural networks. It has billions of parameters. Sorry. Before it was released, GPT-4, this image was famous because they thought that GPT-4 will be much bigger compared to GPT-3. But this is impossible because it's impossible to have so big neural networks nowadays. This is comparable to human brain. So a detail here, the number of parameters are modeled as the area of the circles. But if you think a neural network that we can train and run on a embedded device, for example, YOLO, you can see that GPT-3 is still this, and this is YOLO. So it's very small compared to GPT-3. We know that GPT-3 works very well. We hope that also YOLO works something well. Okay. So, okay, performance, this is the problem. We have to run neural networks with limited performance, and so on. Of course, if you use a cheaper device, you use smaller networks, and the result is bad. Because here contains a lot of operations, more than this. This is a solution that runs on server. This is a solution that runs on embedded device. You see that the bounding boxes are very imprecise, and also the classes are sometimes confused. This is this network quantized and reduced by a factor. Okay, the last problem is the adaptation. As I said before, there are a lot of companies that are releasing embedded device. No worries. And each of these companies has its own tool for deployment. So you have to adapt your neural networks. You check if the operation is supported and so on. And there are a lot of stuff for adapting neural networks inside some particular device. With server, this problem is resolved because there is CUDA, that is a famous library from NVIDIA, and you use that, it's okay. So what we, in general, we do for solving the problem of optimizations. There are a lot of techniques. Some of these techniques was presented before, but we repeat it. One is pruning. Here we can see a very big neural network that is reduced. There are literatures here that demonstrate that you can reduce up to 30 or 40% of neural network sites and parameters without losing accuracy. This is an extreme case where we are going to reduce 90% of your parameters without losing, with a very bit limited loss of accuracy. And there are techniques that are based on weights. If your parameters are not relevant, there are techniques for detecting what are the parameters that are not relevant. For example, if a weight is bigger, probably we take much information, and you can remove these weights, and you got a network, and you can train again your neural network for having the same performance of before. And this can be repeated a lot of things. Distillation method, okay. This is a very used approach. What are the problems here? You have a bigger model here that runs on server, and student model that runs on embedded device. So the problem of student model are a lot. Less power, less computation, less capacity of extracting features. But one of the most problem is that it's very confident. Very confident also when it makes mistakes. For reducing this problem, we have a teacher model that have some results with some uncertainty. For example, dog and cat classification. This is a cat by 90% of probability and 10% a dog. This information, this uncertainty of the teacher model is very useful for the student model for learning better features, because maybe, I don't know, maybe this uncertainty, it works and it regularizes the learning process of the student model. This is one reason. The second reason is that you have a lot of images here, because you have not to annotate all the images that you want, but the images are annotated by your teacher model. So you have unlimited data. Okay, this was all the previous lessons about this. But okay, this is very faster. Okay, you have your floating-point weights. Int8 operations are very faster. So you make some statistics of your weights. You monitor your model during the inference, and you make some statistics. For example, the min-max statistics. You know that your weights are from -1 to 1, and so on, but also better statistics like fitting a Gaussian, and so on. And you transform your floating point to int8 operations. This approach is very, very used, but it takes a lot of problems in terms of loss of precision. For this reason, we have, as before, the training-aware quantization. So because the quantization phase, that is this, is differentiable. So you can propagate your error from the quantization up to the original floating points parameters. If it is differentiable, so you can also optimize your initial weights for making it works. Okay, this is the problem that I mentioned before. So there are a lot of devices with different characteristics. The library ONNX is very famous for it because it standardizes the representation of neural networks. You can have your model in Keras, in Torch, in Café, okay, other unused library. And this is a way for converting all these different formats inside one unique format. But still the problem remains because there are a lot of devices that doesn't support the entire operation set by ONNX. So you have to adapt your neural network. And in Artificialy, so in our company, we have a very fantastic tool that it's able to check all the operations that you have done in your neural network, to check if it is compatible, to run the model and check if they respect the frame rate that you want on your device. And after it, if all of these passages are okay, you can start training and optimizing your neural networks. Okay, so let's back to the video of before of YOLO. Applying all these optimization techniques, we can start from a 6 and 4 millions of parameters up to 4.5 million of parameters in int8. So you are reducing of 20% of your neural networks, and you have int8 operation instead of floating point. And the loss in terms of accuracy is only by the 3%. And here are visible results, okay, the server, so the original model, and the quantized and the pruned model, with the video before that doesn't work nothing. And you can see that the performance are very good and comparable compared to the server original model. Okay, that's all.